In this video, we will be discussing what geometric sequences are. A geometric sequence is when the ratio between consecutive terms is constant. Ratio you can sort of think of as division. So if the division between two consecutive terms is constant, that is known as a geometric sequence. If it's constant, that term is called the common ratio, and it is denoted by the letter R. So if we were asked to determine if these sequences are geometric, there's really two ways you can go about determining that. The way that will always work is take one term and divide it by its previous. 6 divided by negative 3 is negative 2. Negative 12 divided by 6 is also negative 2. 24 divided by negative 12 is negative 2. And negative 48 divided by 24 is negative 2. The division between consecutive terms is constant. Therefore, this is geometric. This is geometric. And R is equal to negative 2. That common ratio is negative 2. That will always work. What some people can do, especially with these easier sequences, is they can see the number you would have to multiply by to get 6 is negative 2. 6 times negative 2 gives you 12. 12 times negative 2 gives you 24. And 24 times negative 2 gives you 48. Either way, you can see that R is negative 2. It's either one term divided by its previous or the number that you keep multiplying by. If we go down here and look at this bottom sequence, this one some people might struggle with as to see what would you multiply by. So, instead of doing it that way, the way you can always do it, remember, is just to divide one by its previous. And if you typed in 52 divided by 104, or you looked at 52 over 104, you would see that it reduces to 1/2. So, 52 divided by 104 is 1/2. And actually all of these would give you 1/2. 26 divided by 52 is 1/2. 13 divided by 26 is 1/2. So here, again, it is geometric. And the common ratio, which is the letter R, is equal to 1/2. The reason we need to be able to find the common ratio is because R is one of the things that goes into the formula. Here we are going to write the recursive formula. And the recursive formula, remember, is just an explanation of the pattern. So not only should we fill in R here, but remember we should also identify what the first term in the sequence is. So in order to write a recursive formula, you should fill in what R is, and you should also fill in what the first term is. So as we said, R in this case, the number we keep multiplying by is negative 2. So I would fill in negative 2 for R. And I have to identify what A1 is. In A1, we can clearly see the first term in the sequence is negative 3. This is the recursive formula. And remember what it says is that a term in the sequence is the previous term times negative 2. So for instance, the fifth term in the sequence is the fourth term times negative 2. And it also states that the first term is negative 3. So that's just an explanation of the pattern. The explicit formula is what we will use to find a term in the sequence. So here's the explicit formula for a geometric sequence. It's very similar to the arithmetic formula in that you have to plug in the first term and you have to plug in how it is changing. So we need to plug in A1 and R. My recommendation would be to put your R always in parentheses. It will probably help with sign errors. So if I was going to write this write this explicit formula, A1 is still negative 3 and R is still negative 2. So A sub n equals the first term times what it's changing by, what I'm multiplying by, which is negative 2, to the n minus 1. That is the explicit formula. this is the formula I can use to find any term I want. So let's say I wanted to find the 10th term. I would have to plug in 10 for the n's. A sub 10 would equal negative 3 times negative 2 to the, and 10 minus 1 is 9. So we would need to do, remember, negative 2 to the 9th first, exponents first, and then multiply by negative 3. So a sub 10 equals negative 3 times, and negative 2 to the 9th is negative 512, and negative 3 times negative 512 is 1,536. So the 10th term would be 1,536. When doing word problems, I would like you to use a slightly different formula. And these are the two formulas. For instance, if something is growing over time, following a geometric sequence, you would want to use the one with a plus in it. And if something is shrinking over time, you'd want to use the one with a minus in it. R in these cases is slightly different. So it is not the number that we are multiplying by. R in these formulas is the rate of increase or decrease as a fraction or decimal. For instance, a lot of problems will tell you that something is growing at a rate of 20% or decaying at a rate of 20%. What you can't do is plug 20 in for R. 20% you would need to plug in as the decimal version of 20%. And the decimal version of 20% is, sliding the decimal over, 0.2. 0.2 would have to go in for R. Or if the rate of decrease was 3.5%, you can't plug in 3.5%. 3.5% as a decimal is 0.035. That is the number you would have to plug in for R. A1 is still referring to the first term in the sequence, or the starting value. So here's an example of a problem in which you would use one of those formulas. Bobby has a bacterial illness, and he has over 1 million bacteria cells in his body. He's taking an antibiotic that is supposed to diminish the number of cells by 1/3 every day. I'm going to skip A and B for now. We're just going to go right to C. How many bacteria would be in his body after a week? Because the bacteria is diminishing, we're going to use the negative version, the minus version of that formula. A1 is referring to the starting value, and we know that he starts with over 1 million. 1,283,342 cells in his body. R, remember, represents the rate of increase or decrease. The rate is 1/3. So I'm going to put 1/3 in for R. And 1 minus 1/3 is 2/3. If I want to know how much is in his body after 1 week, then N, I'd be looking for the 7th term. So A sub 7 would be what I'm looking for, because there are 7 days in a week. And 7 minus 1, I could just probably put 6 right away. So remember to do 2/3 to the 6th power first, and then multiply that by 1,283,342. So if we calculate this correctly, we would find that 2/3 to the 6th power is 0.08779. So if I take that and now multiply it by 1,283,342, I would get 112,600 666. So, after 7 days, the number of cells has gone from over 1,000,000 to 112,000. Now that I've answered this question, it should actually be a little bit easier to answer A and B. To write the recursive formula, remember, A sub n equals A sub n minus 1 times R, and also identify what the first term is. Well, from this line right here, we can see that R, the number we would keep multiplying by, is 2/3. So 2/3 is R, so I'm going to erase R and put in 2/3 in its place. And that's because there's 2/3 of it still left in his body after each day. And A1 is that 1,283,342 number that it started at. So that would be the recursive formula. The explicit formula is actually this line right here. The starting value, A1 times R to the n minus 1. So those would be your two formulas.